In today's video, we'll discover how massive ships carrying thousands of tons of cargo manage to float safely on the sea instead of sinking. Why ships sail safely? Have you ever looked at a massive container ship and wondered, how does thousands of tons of steel and cargo stay afloat instead of sinking straight to the bottom? It all comes down to a perfect tug-of-war between two invisible forces, gravity pulling down and buoyancy pushing up. The physical paradox. On paper, it looks like a paradox. You have an immense downward gravitational force pressing onto a fluid, yielding surface. Without the right design, that weight would simply overwhelm the water. So how do we tilt the scales in our favor? The boundary between sinking and floating. The secret is in the balance. When an object is too dense, the downward force overwhelms the water's resistance, and it sinks. But when we shape that same material into a wide, hollow hull, the downward force is perfectly counterbalanced by the upward fluid force. This is the thin line between a shipwreck and a successful voyage. Archimedes Principle. This is Archimedes' principle in action. Step A. As the ship sits in the water, it moves, or displaces, an amount of liquid equal to its own volume. Step B. The weight of that displaced water creates an upward buoyant force. If the water you move weighs as much as the ship, you stay afloat. Dynamic equilibrium. Buoyancy isn't just luck, it's a dynamic equilibrium of mass and geometry. By engineering the hull to displace exactly enough fluid to match its immense weight, we can move thousands of tons across the ocean with total precision. That is the science of sailing safely. Now you understand why ships carrying tons of weight can sail safely without sinking. All thanks to Archimedes' Principle. Subscribe for more simple science explanations.